Okay. I think we have started recording, right? I think. Is it okay? Yeah, recording.
Yeah, it's recording.
Okay, fine then. So today again we'll talk about our Titanic data set, right? So what we have seen so far is we have talked about this hypothesis, questions, all this stuff. If you have any other questions, you can add it here today, right? You can add if you have anything, right? So we have imported NumPy, we have imported Pandas, matplotlib, cbond. This is a command if you're using Jupyter. This is required sometime, but sometime you don't need actually. But it is safe if you have this line. That means graph, whatever plotting you're doing will be displayed on the next line, not cell. Okay. Then this one is about RC params. We'll talk about this later on. This we have seen. Then we have loaded Titanic data set into a data frame. Our data frame name is Titanic underscore data. Then we know what is the shape of the data. We have 891 rows and there are 12 columns. And it is being displayed here. First column is our passenger ID, which is integer 64 type. Survive, again integer, PC class, integer, name, sex, age, SIP, SP, then parent and child, ticket, fare, cabin, year. All these are columns having different data types. Now, actually, we need to understand what is the data type. All these are actually, yeah, little bit of statistics is required now to understand these data types. Okay. So let me talk about statistics today. If you will spend some time, maybe 10 minutes, to understand different data types in statistics. Okay. Because if I come here, we need to understand those data types. All right. So statistics, it is as per Wikipedia. It's all about data collection, sample collections, populations, and analysis, presentation, all the stuff like that in statistics. Now, let us try to understand what is population. Okay, what is population? What does it mean? Suppose I want to find out the average height of all Indians, right? Average height. What will be the average height of all Indians? Okay, how do I do it? I need to ask everyone, right? We have 132 crores today, right? Husband, how many Indians are there today? 132, right? Our population?
Yes.
We have around 132. So I need to ask each and everyone ask what is your height, what is your height. Then I'll sum up all of them, right? I'll sum up the total height. Then what I'll do? Then I'll divide. I will divide by what? You sum up first all the heights, then you divide by what? Number of Indians is 132 crore. Then I get average height, right? This is actually population. Entire population of India is being asked to provide their heights. 132 crore, you need to ask that. You need to take the data from 132 crores and do this calculation. Sum up all of them, then divide by 132 crore. Then you get average height. Now, this is not a very easy task, right? So in statistics, what they would do is instead of taking entire population data, they will take subset of this. Okay. Only this subset of the total population. Okay. Only this much. Maybe some 30,000, 40,000 people they will ask. Okay. That is called sample. That is called sample data. This is called sample data. Okay. Now why this sample is important is like it's very interesting because in machine learning we don't get this population data. Okay. What we get is some sample data, like some 2000 records. Okay. Now, if I build a model on this sample data, this model should be able to describe about the population. Okay. We call it prediction. We call it prediction because after learning the sample data, the model should understand what is outside this data, outside the sample data. Okay. This model should be able to describe, okay, this means this. So this is basically prediction. That is what you would see in machine learning. You get some sample data and it will generalize everything and you get the information. It will be able to predict the population, that unseen data. Okay. That is the concept behind this. That is how the machine learning is built. Okay. That is the logic. Now, there are different type of data types in statistics. Let us talk about this. Right. Number one is data type is, it could be numerical. This is number one. Or it could be categorical. Okay. I should have pen. I don't know how to use. I have pen actually, but I don't know how to use it. I'm not liking that pen. I have actually electronic pen. I am not liking to use that one. I don't like it actually. I'm not able to handle that actually. One is called numerical, other is called categorical. Numerical is like in numbers, like your age, temperature, or your shoe size, everything, whatever number you're seeing. Okay. Categorical is basically like your name, gender, cities, states, animal names, all these are categorical. Now, this categorical is a numerical data types is divided into two. Okay. One is called continuous. Continuous. N-U-S, right? Continuous. One is continuous. Then other is discrete. So continuous, you can imagine like you have a number line starting somewhere from minus, somewhere 0, then somewhere to the plus side, right? Like from, it's a continuous number like this, starting somewhere and ending somewhere continuously. It doesn't stop. Like our, you can say our weight. I have 65 kg something. Someone will have 64 point something, like that. These are called continuous number which you can see on the number lines. Okay, this is called continuous number. Okay, discretes are basically number, but they are not continuous. For example, when I say shoe size, is this a continuous number, right? Shoe size could be what? 5, 6, 7, 8, 9, something like this only, right? Do you get 5.5, 5.6 shoe size?
No.
You don't get, right?
Yes.
You don't get that. So it is like that only 5, 6, 7, 8, 9, 10. I don't know 11, 12 is there or not. But these are called discrete number. Okay. This is called discrete numbers. It's not continuous. They are number, but like for example, I can say I can add like number of parents or parent. Either you will have 1, 2, or I don't know whether we can have 3, 4. Okay. But these are numbers. Okay. So this is called discrete numbers. Now on the other side, we have in categorical data types, we have got 2 more here. Here also we have 2 types. Okay. Here also we have 2 types. One is called nominal. Nominals are any character like your name, your city, state, anything other than numerical type, but it's a string, character or string, that is called nominal, just a name. Nominal means name. And the other one is ordinal, which is interesting. Okay. Ordinal. When I say gender, you have male, female, right? Is this a ordinal? Can I say it is ordinal or is it nominal?
It's a nominal.
This is actually ordinal because it is indicating there is some quality it is informing, right? There is a quality here. This is dividing, but this nominal it will not divide anything. But this is still like okay. Let me give some other example. Like I say, let's suppose this is a customer satisfaction kind of data. Okay, satisfied. Not highly satisfied, kind of and not satisfied, right? So we are seeing some order here, right? There is an order. Satisfied, highly satisfied, not satisfied. We are seeing some order here, right? So these are called actually ordinal data types. Okay, you can say like in first class, first, right? First, second, third, like that. All these are actually ordinal. Okay, it is indicating some position, some order. Okay, that is why it is called ordinal. If you look at your data here, yeah, this data. If you see this data, here is the data, Titanic data. Titanic data. Titanic. Dot head. If you look at this data, PEC class, you have 1, 2, and 3, right? So this is actually ordinal number. It is an order. Order position is here, right? 1, 2, 3. Right? There is an order here. So this is called ordinal. But look at it, survive. You have 0, 1. Actually, there is no order here. There is no order. All these are actually categorical data. Survive and physical, though it is showing numbers, but these are actually categorical data. These are not continuous number or discrete numbers. These two are basically categorical data types. They are not numerical. They are not numerical. Name is numerical. This I was talking about the sex. Will it be ordinal number or it will be a nominal number? Think about this one. Age is your numerical, which is continuous. SIB, SP. This is a numerical, right? This is numerical. PARCH, this is also numerical. Ticket is categorical, nominal. Fare is a numerical. It's a continuous number, I guess. Yeah, continuous number. Cabin is what? Will it be nominal or ordinal? Cabin number?
Nominal.
Correct. What about this embark, SC, you have SC, S, blah, blah.
Okay.
This will be ordinal.
Yeah.
This really, we don't know, right? It is not order. There is no order here.
No order, but categorized. It can be categorized like there is like a high, upper class and lower class embarked, right? Embarked is
Yeah.
that.
Yeah, no, this embark, we don't have any classification like that.
Okay.
This
Embarked
is
is
just
the
the point of
station name.
embarkment. It is a short, I mean, that code. It's just a code. Otherwise, they would have written here some London, Paris, something like that.
Okay. Okay. Yeah. Then it is nominal.
Yeah, this is nominal, okay. So that is how it is. But every data types is giving some meaning to our machine learning, okay. If it is categorical, if it is nominal, you have to treat the data in a different way. If it is ordinal, you have to treatment is different. So it changes according to data types. Right. So that is why we need to understand the data type. Then accordingly, we need to take action. Otherwise, you are going to get a very wrong answer. Like for example, this one. Survive 0, 1 looks like a number, right? It looks like a numerical data. This is actually not numerical data. 0 means survive, not survive, 1 means survive. This is not actually numerical data. Okay.
Yeah, it's a Boolean
So,
data, right?
yeah, it's a Boolean data. This is basically, is it a nominal or ordinal? There is no order here actually. There is no order here. We don't know. There is no order. It's not like first, second, third, right? There is no order here. But here you can see order here. Like first class, second class, third class, they have mentioned right here. Where is it? Of the first, middle, lower. Oh, this is, yeah, this is order, right? Upper, middle, lower. Proxy for socio-economic status. Wow. Upper class, middle class, lower class, right? So this is the ordinal number, ordinal category, okay? It's not nominal. So we need to understand the domain. There will be some description of the field. Then from there we need to identify whether this will be a nominal or ordinal. Okay, that understanding will come from the data set description. Okay, and if you are domain expert, then you will be knowing what it is. So this is all about data types in statistics. Remember that you have population. Population means entire data. From the entire data, we take only the sample data, and we'll be using this sample data in our machine learning. Remember that, okay? There will be a lot of mention about this sample means we are talking about this set of data, not the entire set, only this part of the entire set. That is called sample. Right. There are some hypotheses built on this to predict this one. Okay. So now we know data types. So let us try to understand some statistical measurements. Yeah. Use this command. You have this command, right? Describe data frame dot describe include equal to all. You have this command, right? Did Meena join today? I think she is busy. She did not join. You got this command, right? You are able to see the same data. This is all about the data, but it is basically statistical information. Okay, like the first line count, it will show you the how many records you have in the data sets. Okay, so you get, see, there is some problem here. Okay, there is some problem. This will give you the non-null numbers count. Okay, like 891 is the number. Say age, I have only 714. Here I have 891, 891, 891, 891, but Kevin, I have only 204 out of 891. So there are so many null values here. Embark, we are missing 2 records here, 2 data missing here. Okay. Unique, it is on categorical. See, this guy, since the data frame is in like this and numbers, it's not finding out the unique. Okay. Name, there are 891 unique, means all passenger names are totally unique, different names. Okay. And in the sex column, we have only 2 unique, right? Male and female. Age is a number, so cannot find out the unique. This is again number. This is again number. Ticket, there are 681 unique tickets out of 891, means for one ticket you have more than 1 passengers in some cases, right? That is the meaning of this. One ticket having more than 1 passengers. Okay. Fare is a number, so you don't get unique. Cabin, there are 147 cabins only, unique cabins. Right. And there are 3 unique embark. Okay. The point of embarkment, you have only 3, like SCD, something we have seen, right? So likewise, the top, this is again on categorical data. Say this is kind of a random, okay? Top here on name is whatever you have seen here is basically a random number, random names, because all are unique. So it is just picked up one of them. If you run it again, you might see something else here, okay? Because all are unique, all are unique. This is also very funny. Top, it is giving top, male, female. It is means male. There are more males than female. Okay, passengers. There are more male passengers than female. That is the meaning of this, right? Likewise, this ticket has maybe more than 1, more than 2, more than 3, like that. 1 6. You can note down this ticket number. 1601. This ticket number, I think this guy has so many passengers. Let's see how many passengers we have here. You know, right, how to query? That day we have seen. This is not ticket, no? Ticket, data. Okay, ticket equal to what? Equal to what is the ticket number? 1601, right? 1601. See how many passengers we have. Wow, so many passengers. Wow, 1, 2, 3, 4, 5, 6, 7. There are 7 passengers. Wow, all are male. 22, 28, 26, like these are young chaps, right? Young people, right? 32, 26, 28, 32, and all are male. Look like young boys. 3 plus 3, yeah, 3. And some people survive, some people did not survive, right? Wow, this is a very interesting case. Ticket number 1601.
Hello.
Yeah, Asmin.
Yeah, I ran the same command that above one, include all, like describe one. I got different data in top thing.
Yeah,
This
top
top.
here now, you might get something else, okay?
Why so?
Because I have 891 records and there are 891 unique records. Means all are unique. So this will, you give it unique, you will have some random value here because of this nature. If I have at least one record which is duplicating, which is appearing twice, then that particular data would have appeared here, okay? That
But
is the
we have
meaning.
same data, na? So
No. What I'm saying is, for example, see, you look at here, male, okay? Male and female, right? It is counting. It is counting how many males are there and how many females are there. And it is checking which category is having more number of records. Like male, here it is showing male. Means there are more number of males than female. Understood?
yeah, that I understood. But
But
like
here, yeah, here you'll never get because all are unique. A random, it will pick up random. That is what they have mentioned in the documentation. If there is no kind of top kind of information for that particular column, it will pick up random data. That is what it is doing here. I think if I do run again, I might get something else. Now it is coming the same thing. But definitely you will get something else, I will get something else.
ticket is
Okay?
also different on my screen.
Yeah, it will be different. No, these will be different. I am telling you this. Name. You will get something else.
Ticket. That's
Ticket.
1601. Yes, that is also different.
Huh? What did you get?
I played the same command.
No,
Describe good all.
there are 7, that is what I'm saying. There are 7 frequency of this. This guy has 7 frequency, that is what I'm saying here.
Yeah, I got the same result. I mean, because that's the ticket, right?
Yeah.
It cannot be different.
Yeah, 7, there are 7 it seems of this ticket, there are 7 records.
It's showing me frequency 7, but how it could be different? Ticket
Then there
name
could be another 7. What is the number you're saying, ticket number?
CA.2343.
GA
Dot
dot
2343.
2343.
CA. CA.
Oh.
CA.
Uh,
Dot.
hmm.
Yeah, rest is same.
This is the ticket number.
Uh-huh.
No?
No, there is no ticket.
Shall we run it again then?
This ticket is not there.
Then why?
You're reading the same file, no? What Basu shared.
Yeah, it could be same file only.
Yes,
Right.
yes, in file. After Titanic, CCS, CSV.
No, it will be same only.
Share your screen.
Yeah, let me share my screen. Yes, this file, right? So,
Come down.
so
Describe.
you have also ticket names like this, PCA5.
No, go down. Describe that command.
Yes,
Yeah.
here it.
Yeah. Is it CA or blank? 2343.
Shall I give
Dot.
you a remote control?
Dot, huh? No, the ticket number could be, I mean, you might, but CA blank or what, this one?
Run this command again.
Huh?
No, I did it.
Same
It's
thing.
the same thing.
But CA232, I'm not getting 2343. Any one of you getting the CA2343?
No.
CA dot, huh? Asmir?
Yes, this is C dot.
Cabin number is B96, B98, right? Okay, let me check with cabin number. B96, B98, right? B96 and B98, right?
Yes.
Cabin number. But cabin number is a totally different ticket number. 11360. I don't know data कैसा how it is कैसा तो 96 B98 okay.
Which command you did that? Like, I will find. I will try to find all the details with this ticket.
You can use change it. You can use this command, but instead of Kevin, use ticket. Here you mention ticket, okay?
Oh yeah.
Then ticket number here. Ticket.
Just I have to put something else also.
Yeah, start square bracket. Inside that you have to write again Titanic data. And again square bracket.
Square bracket, double quote.
Inside.
Opening,
inside
open.
that. Inside that square bracket. Inside double quote you have to put ticket.
That column name.
Column name. Yes.
Then outside.
Equal to in double quote. Ticket name. Ticket number.
Done?
Yes.
Nothing. So it's a garbage value.
No, it's coming. CA dot, then give space, TA dot
Blank.
yeah
Blank.
space then enter. Yes.
Maybe there are 7. Come down. Maybe 7 records are there. 1, 2, 3, 4, 5, 6, 7.
Yes.
7. That is what.
Yes.
Here also we have 7.
Yes.
So that is why it is picking up randomly. Yeah, here also we have 7 records. Here all male, female, oh, full
And
family.
here
This,
marked is SSSS.
oh man, this is a full family and nobody survived. My goodness, right? A full family. See, no
Yeah.
age. Junior, junior, Henry, Miss, Master. See, young kid, Master, Miss, very junior.
Yeah, they are total 8 or
Oh,
something
full
like
family actually.
siblings.
Maybe all of them died. Oh man, very bad. Yeah, $69, 69.55 pounds.
Is this real data?
Yeah, all is a real data. All these are actually real data, actual data. Anyway, fine. Okay. Oh, got it, right? So if you have any duplicate like this, right? More records you're seeing on this particular category, then it will pick up the anyone, either of this, any random number it will pick up and show there. Idea is to how do you upload? Okay. Oh, okay, that's fine. So top is gone. Frequency like counter only, like we are seeing 7 records. So it is showing up 7 records. And we are doing 4. So in this cabin number B96, B98, there are 4 records. 4 records. This particular cabin is, I think, showing up more times. That is, it is showing frequency 4 times. Then here we should be interested in this. Okay, mean, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and the max. So this 1 to here, okay, will be on numerical data. Now, if I remove this include, okay, remove include, I will see only numerical data, okay. All others are gone. Your name is gone, embark is gone, all categorical data gone here, okay. You will see only numerical data. So for this mean standard up to here is only for categorical data, numerical data. Mean means average, like average, you know average, right? I say suppose mean, what is the average of these two numbers? 5, 10, 20, right? Average of this, what is the average of this? NP dot mean of what? Mean of M. 11. I think there is another way. We can write this also, right? Meena? Rupali? No. List cannot do. Okay. If it is ND array, we can do it that way. So mean is basically average of this. You sum up all of this, like 5 plus 10 plus 20, right? This is the sum. And you take the average of this. So I have got 3. So I put 3 here.
21.
How come 21?
Oh, I think you should put bracket or
brackets. Yeah,
something.
bracket everywhere. Okay. 11. That is called mean. Okay. So mean is, it indicates about the location of the number, this sample. These are called sample. Okay. I have This is sample number 1, sample number 2, sample number 3. Okay, 1, 2, 3. Right. So this number mean indicates a position in the list in this particular sample, where it is. It will indicate some position here. We call it location. These are basically, it indicates some location. Okay, mean indicates some location. Remember this. It will indicate some location in the sample. For example, it is showing 11.6 means it is somewhere here. Okay, it will be somewhere here. If I change it to something else, if I have another 10 here, np.mean, yeah, 11.25 still it is showing. Let's make it 30, 16. So the location is changing. Okay, location is changing. So if I have a series, if I have a sample, and if I know the mean of that particular series or sample, I should be able to tell you that, okay, this position is somewhere here. Okay. Okay. This particular series has got this number and it will be somewhere here. We'll see that graphically. Okay. No, we are not showing graphically, so it's very difficult to visualize, but I'll show you graphically. Right. How do I show? Okay. And there is something called median also. Okay. Median. This also indicates some location. This also indicates some location. np.median. It is showing 15. Now let me pick up something else here. It will be easy to understand. Let me pick up 20. It is showing still 50. Oh, I didn't take this one. I have to take this one. So median is basically you sort the number, this particular series, in ascending order. Okay. If I sort this number, what I will get? Ascending, I will get 5. Then I will get 5. Then what? Next number is what? 10, right? 10. Then I will get 20. Again 20. Then 30. So how many numbers I have? 1, 5, 5, 10, 20, 20. 1, 2, 3, 4, 5. I've got 5 numbers. You divide the numbers by 2, okay? If you divide the number by 2, 5 means you'll get 2 this side, and it is 2 on the other side, and in the middle you will get this 20. So this is basically median. Let me put something else here. Okay. So it is picking up this one. this 20. This is the middle. Median means middle. Median means actually middle number. So the meaning of median here is 20% of this population are this side, and 50% of the population are on the left side, and 50% is actually on the right side. This is the meaning of this median. Let me give you a very classic example, okay, to understand it, where it is used. Suppose you have joined this company A, okay. The salary of this company A is something like this: $10,000, $20,000, $30,000, $40,000, and suppose 10, 20, 30, 40, $50,000, okay. And there is another company B, okay. Take this one. This guy has got 20,000 and 30,000, then 40,000, then 60,000, then 80,000, okay. So suppose this is the salary structure of that company. When the employees are having this kind of salary in this company B, and in company A you have like this. Now if I take the mean of this, okay, mean salary, let me find out what is the mean salary of company A. I can try this one. I get 30,000, right? Now if I take mean of this, okay, so which company you are going to join?
B.
B, right?
Yes.
So because company B has 46 average salary, okay. Now company A has only 30. So I will join company B, right? Now see this one. I will take median. Median of A, then NP, median of B, okay. Now median is changing, okay. Let me change this one little bit, okay. Median still 50, right? 50. I have mean 50, but this is median, okay. So the meaning of this is, if you look at this one, you are seeing actually 50% mean you are seeing right here for this guy, for this organization, you are seeing 50K is the mean salary. Means I'm expecting that I will get 50K, okay. But actually the median of this particular organization salary is actually 40K. Okay, because we are seeing a big number here, 100K. Okay, because of this, we are seeing this particular mean. Okay, but the median is 40 only. So if you try to find out what is the average salary of an organization, we don't take actually mean. We don't take the average. We take median. That middle point that location middle point, will pick up the middle point, not the average. Okay. So the median will help you to find out if you have null values anywhere. For example, where is the data? See, Embark, I am seeing 2 records are having null values. And Embark is a categorical field, right? How do I fill in this blank data? How do I fill in that blank area? Shall I use average? I cannot take average. Shall I use something else? So since it's a categorical, then I need to figure out what I should take. But for example, here age. Age is a numerical field, right? So many fields are having null values. How do I fill up those null values? Okay. How do I fill up those null values? Embark, then you have that ages. How do you fill up? So we are trying to figure out which technique will be used here. Okay. Using some statistical information, we'll try to fill in those data. That is why I am discussing about this average, mean, then this median. Okay. You got some idea?
Yes, Baba.
Yeah, this is a very simple formula, very easy to understand. But what we need to understand is where I should use this. We'll see some examples where to use it, okay? Because there are some null values we have in Titanic data set. We'll be using those formula, how to fill up those null values, okay? Then point of summary. Okay. Yeah, let's talk about this. This is also statistical information, okay? Histogram. We call it histogram. Histogram. It will talk about like we said, right? This frequency. Include a column. Include. Here we have seen some frequency, right? Some frequency you have seen here. So based on the frequency, it is going to plot the graph. This is called actually distribution. This is called distribution graph. Okay. Like if you look at the age, 0 to 20, it's not clear. Beans, let me change the beans. Beans equal to 10, suppose. Okay. It's not clearly coming. Let me take only one. What is age? I'm taking only one variable here, one column, okay? Then 20. It is how to read this data is, this graph is, this thing 0, maybe this is 9, okay? So up to from 0 to 9, this is the count. So we are getting around 51 counts, okay? From 9 to maybe this one is 18 or so, so I will get this many counts, around 48, 49 counts, okay? This is the meaning of this graph. So from here you can say, mostly I have got very old person here, see? From 71 to 80, there may be only one here. So on an average, you will see, mostly people are, these passengers are between what? This may be 18 to some 25 or so, or 24 or 23, okay? Because see, the count is very high, 175. So this is how you need to read this graph, okay? So this indicates mostly people are very young, mostly 18 to 22 or so, or 23. You see that one. 175 people are there. Passengers are there between 18 to 22, something like that. Okay, this is how we need to read this one. So you have got young kids also, like 0 to 5 or something like that. You have around this many guys, around 51, 52 guys are very, very young actually. Very, very young. Okay. So this is very good from analytical standpoint. Based on this, you can do some other calculations, okay, some other analysis. So 4 o'clock. You have any question on this? How to read this graph, Yupali?
No question.
Yeah, this is somewhat very simple to read, okay, but this is something like distribution. It looks like a distribution, but it's not actually distribution. We call it frequency distribution. Frequency distribution. Okay, it is already 4 o'clock, right? Shall we stop here?
Yeah.
So any task for us?
Hello?
Any task for us?
Yeah, now we have seen this age, right? You run on this one on another field called fair, okay, and see, or try to run on. Now this can be combined, okay. We have done only for age, but this same graph can be modified again. I can separate out, but here both the genders are mixed up, right? Male and female, okay. Male and female both are mixed up here. I can separate it out. Male one diagram, female another diagram. Same command, but little bit some modification is required here. Can you try tonight sometime? You will have two diagrams at the same time. One on the left side, other in the right side. One will indicate suppose male, other side will indicate female. So that you can compare how many males coming under a particular age group, how many females coming under the same age group. It will be very good for comparison. Try that one, okay? You need to just little bit, some modification is required here in this command. Little modification is required here. There will be another parameter and you will see two graphs coming up side by side and you can compare. You can do it tomorrow, not a problem, but try to explore this command history and you will see that. Okay. Hist means histogram.
Histogram.
Okay.
Okay.
So tomorrow we have, right? Tomorrow we'll see again.
Yes.
Okay.
We'll see it again tomorrow.
Yeah.
Okay.
Thank you, Basu.
Thank you. Okay, bye-bye.